Did you have any questions about the homework first off?
No.
Okay.
Self-explanatory.
Well, I have the quiz up. You do.
Pulling it up right now.
Cool.
We kind of pulled it up earlier just to kind of see, and
They're really
we
easy.
figured out some of them. So
Oh, okay.
Yeah, we right before we got started today.
but it's just
Okay.
pretty much knowing how to run the software.
Mhm.
So
Which I would rather do than anything else.
Yeah. Yeah, exactly. Okay, so for 3,
all right. No, how about reject? Sufficient evidence to indicate that at least one mean is different than the
I
others.
put true.
I would agree.
yeah.
Okay.
Yeah, when we reject the null.
Okay. Then let's look at number 4, requirements when checking. This one is in the book. I remember it being the data in each group are normally distributed, and then the variances are equal to in each group.
That was in the textbook. Like.
Okay. I think they all have to be positive too.
Because if you
I
go
know
to
the F value
3
is
point,
never negative.
it says like there are 2 requirements of it when it must be checked. The data must be normally distributed, and the variances are equal for each group. That's all it says in the book.
I think you're thinking about the, is it the P? No, it's the F value.
It's the F. Yeah,
Yeah.
the F value.
Never negative.
Yeah, okay.
So we'll put the last 2 for the NOVA.
5, check if
Mhm.
it's normally distributed, do the following. That's in the book too.
That one.
It's still in the same section.
It's the Q plot, right? Yeah.
We check this by creating a QQ plot for each group separately. That's in the same section, 3.2, requirements.
Yeah, that.
Sweet. Number 6, we assume the variance in each group is the same if the following happens. That's in the same section, isn't it? The rule we use is if the largest variance is less than or equal to 4 times the smallest variance, then we conclude the variances are equal.
Okay.
So that would be
Number 2.
Okay.
the second one?
Yeah, so largest variance is less than 4
Right.
times.
2 times, yeah.
The smallest.
Okay, this one I was kind of confused on.
Number 7.
There are 3 samples, there are 3 pairs. 1 to 2, 1 to 3, 2 to 3. How many pairs are there when there are 4 samples?
It'd be 8, right?
There are 3 samples, there are 3 pairs.
What
Would there be 4 pairs if we had 4 samples?
I would say 6. It says 3 samples, 3 pairs.
Right, but if you think we have options 1 and 2, 2 and 3, 3 and 4, then we have 1 and 3, 2 and 4, because you can pair them up differently, right? So like with this 1 and 3, the 3 samples, they have 1 to 2, 1 and 3, 2 and 3. That's the only combinations you can make. Does that make sense?
Yeah. It does.
So for 4,
Yeah, because then when you throw 4 in there, each one.
It would be 4. I mean 8.
because you have,
Yeah. Then,
We can try it.
okay.
yeah.
Running the
Hey,
software, that's where it got
shoes.
kind of confusing.
Okay.
Let's open it up and look.
Smallest variance. Okay.
So this one we still have to automatically recode.
Mm-hmm. We would just do the footwear.
Right.
Okay.
That's
Yeah.
all we did.
Okay.
Mine's being slow coming up.
No, it's always slow.
Okay, this one, let's get it recoded.
Okay.
And then let's see, we would do the descriptive statistics explore. All right, is that where you went?
I went to did analyze. Yeah, descriptive. I did analyze, compare, and then one-way ANOVA,
Oh, okay.
and then dependent as kicking in the factors, the code.
Sweet.
But I don't see on here variance. So I don't know what else that
Let me see.
Minimum variance and the maximum variance is what the next two questions ask, yeah?
This guy.
Yeah, because we have the lower and upper and the minimum, maximum, and then they give us would it be
Okay.
DF?
So go to transform, or sorry, let me.
Oh yeah, it's in the book. If you go,
So go to analyze and then descriptive statistics,
Okay.
then explore. It'll pop up where you have dependent list, factor list, and label cases by. So dependent is what we're measuring, right? Or what's going to stay the same, which would be the kicking accuracy.
Yeah.
And then the factor list, the thing that would be changing would be the footwear they're using. And then label cases by coded footwear, because that only gives us the one category 1, 2, or 3, or 4, right? So do that. Hold that table,
Then
and then it'll give
all
us
I
the
did-
variances.
yeah, I just looked at all of them and picked the minimum out of all of them, like what was shown as the smallest.
So it looks like on here the smallest is going to be, if you look at all of them, I have 27.358 as the smallest.
Oh, here we go. Okay, yeah.
Did you find where you see the variances?
I see the chart.
So keep scrolling down. Category that's gray that goes A, B, C, and D, and E, and socks.
Yeah, okay. Yeah,
Inside that, there's going to be underneath median variance number.
Oh, okay, yeah. Is it the same? Not the same for each one. So what variance is it asking for?
So the lowest, and if we look at all of them, it looks like
just the lowest.
27. So, oh wait,
Okay.
Is it?
it'd be category C, right?
27.221.
Gotta change ours.
27.208.
208.
Those decimals. Then the maximum. Looking through all of them.
Maximum would be the 53.
158.
Yeah. So that would be category D.
Yeah.
The test for equal variances is satisfied for these data. True?
I would say.
I don't know.
Yeah, I don't know either.
I'm just gonna put true for
We'll put
now.
true.
Yeah.
Construct a QQ for each of the 6 samples.
Each of these samples are approximately normal based from what you see in the QQ plots.
Let me check. QQ. So QQ is found in analyze, right?
Graphs.
I think it's crafts.
No, that was the other one we had to build.
I just found it a little while ago. Let me look. Oh, okay. So yeah, it's analyze, and then under descriptive statistics, at the bottom it says QQ. Code. And then I'm going to throw the variables of foot code in.
Okay.
The coded foot codes or footwear code. And let's see. So that pulls all the graphs. And then is it just asking us if they look normal?
Yeah.
I would say they look normal, like a cube graph.
Yeah.
Perform a ANOVA test. The estimate to observe the p-value is 0.081.
Okay.
Then remove the SOX data and perform the test again. What is the p-value when we remove the SOX data?
Okay. So Jensen, do you want to do just the regular ANOVA? And then I'll go through it and remove the SOX and see where we're at.
Okay.
So do a regular one and make sure we get that.
Make sure the p-value is 0.081.
Okay.
Then I'll remove the SOX.
Do we need to open the new data?
No, it'll still be that same, the SOX or the footwear one.
Yeah.
But when you open the one-way NOVA, dependent list is going to be the kicking accuracy, and then the factor is going to be the coded foot wear. Did you figure that out?
Wait.
If you need help where to find it, I can help you.
Well, I'm just really confused on like I just don't.
So do you have your footwear one open, right?
Yeah.
So go and on analyze, go down to compare mean. And then go one-way NOVA.
Yeah.
And then dependent list, put the kicking accuracy.
Okay.
And then on the bottom where it says factor, put your coded footwear.
Okay. Yeah, I did that already.
Okay. And then if you look,
yeah, okay.
it'll give us a SIG where it says
okay, yeah.
SIG. Is that 0.081?
Yeah, it's
okay.
Yeah, it is.
Hey,
That is.
so we just
Sorry, I was just really confused.
No, you're good. Sorry.
So we ran it and we pulled out the SOX data and got 0.309.
Okay.
So that's the answer.
309.
Yep.
0.309.
0.309. Yep.
Test statistic for ANOVA is the F statistic. The p-value is the p-value, the area to the right or the left of the F statistic.
The p-value would be the left of the statistic, of the F statistic, right?
P-value is the right.
Oh, is it?
I think it's that.
Open
Yeah.
Grow up.
I know it's in the
Here, right here.
book.
Yeah, it's the right. Sorry, I was double checking. So let's move
Now
to
we open the new data.
hot dogs.
Ugh.
Okay.
Dogs. Good thing we have a test this week.
I know. Good thing we have a test review.
Yeah.
We still need to find margin of error. That's something we've been dying over.
I emailed her about that, and she said I think the lesson before in the question and like conversations thing, someone asked her, and she went through and like described how to find it
Okay,
Oh,
I'll
wow.
go look at
and look at it. Yeah.
I'm glad we weren't the only people who didn't know.
Yeah.
Seriously.
Yeah, definitely.
Okay, so I just got that one open. I'm gonna recode because I assume it's gonna ask us to do that.
Mhm. Would recode the type.
Yeah. Perfect.
Okay.
Let's examine the calories first. Construct the QQ plots for the calories for each of
Okay.
the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met.
Okay.
What?
Q-
Asking for the calories first.
Just calories first. So slide that one over, and if it loads, there we go.
Then it says construct the QQ plot
Okay.
and compare the variances to determine if the assumptions have been met.
Mhm.
So first we gotta decide if the assumptions have or have not been met, and then we can pick which explanation would best
What
fit.
assumptions are they talking about? I guess I gotta read up higher. Let's see, they recorded the time. Oh, really interesting.
So
Does that look normally distributed, that QQ plot? I don't think so.
no,
Yeah, I'm looking right now.
Because it's all over the board.
I would say no.
Mhm.
So
So I would assume it is unsafe. So assumptions have not been met.
it is not safe to assume each group comes from a normally distributed population, but we can assume the variances are equal. Or can we not assume the variances are equal?
I just don't know.
I mean, I might try the last one,
That they're equal
that they're not,
or not equal?
assume that the variances are not equal, and then if that's wrong, then I would assume it's the second one.
Okay. So let's guess then on that for D.
That's just what I think at least.
They're not met, not normal, and variances are not equal. Okay, run a NOVA test.
What conclusion can you draw? I hate questions like this. I'm not good at them.
Is it still asking about calories?
Yes.
Mhm.
We have sufficient evidence to claim that all 3 hot dog types have the same mean number of calories. We do not have sufficient evidence. Then reject the claim that all 3 hot dogs have the same number of calories. We have sufficient evidence to claim that all 3 hot dog types have a different number of calories. We have sufficient evidence to claim that at least one of the hot dog types has a different mean.
Let's see. I would say we have a sufficient
Well-
evidence. The p-value is 0, right?
Uh-huh.
But I don't know if that really means or changes things.
Yeah. I mean, because in the ANOVA thing, the mean square, like between the two groups is like 8,000 and within the groups is 500.
Second one?
Between the groups and within the groups.
Yeah, it might be the second one because we don't really have like to reject that they do.
Did it? Yeah, okay.
Maybe.
Sodium level. So same thing, but we're just doing sodium.
Ugh, I hate these questions.
Okay.
So is it asking for a QPOT first?
Mhm.
Yep.
Yeah, calorie.
Have the assumptions been met to use an ANOVA?
I would say
Yeah. That looks pretty
these
dang
were the ones like on the
close.
first test I always got wrong because
Yeah, because
fine.
That one's pretty dang close though. But is it? I don't know.
I feel like there's equal amount of dots outside of the line than on the other one, right? Isn't that part of the
okay.
and just knowing how tests work, they'll probably have us go both ends of the spectrum. So if calories is not normal, this one's probably normal.
Okay.
If that's a way to think.
Yeah. Well,
Um,
is there something in the textbook about like variance assumptions?
That's what I'm looking.
it's not looking promising. Not really. There really isn't anything in the book.
Hmm.
So
Okay, well, because with the null and the alternative hypothesis, the null is that all means are equal, and the alternative is one or more of the means differ from the others. Does that help? Our question, kind of. The means differ from each other in comparison to the variability in each group. Then we conclude that the means are not all equal. If the means do not differ by much when compared to the spread of the data in each group, then we do not reject the hypothesis that all the means are equal. Or by much. So for sodium, I think, well,
Also, I don't really like number one.
yeah. Okay.
But well, I just don't like that it's okay to assume.
Yeah.
I would say
Number two, it's safe to assume.
I think they have been met though. Maybe they haven't. I don't know. I'm willing just to kind of pick.
Well, does it look normally distributed? The
Think so?
Q plots?
So I would say maybe the second one.
I would say it's more normal than the other one.
Okay, then yeah, let's try the second one.
Okay.
Despite the possible problem with the QQ plot,
What
what is the p-value for this
P-value.
test?
So that's just the SIG, right?
For all three.
But it's just sodium again, right? Yep, that means sodium levels.
So is it 0.179?
Yeah.
That's what I got, yeah.
Mhm. Yeah, that's what I have.
Last question, and then the moment of truth comes.
What conclusion if the level is
Okay, so the
Okay.
p-value is greater
right?
than that. So we have insufficient evidence.
So
Uh,
we do not have sufficient evidence.
At least one of the hot dogs have different.
So we're rejecting the claim.
Well, we got to decide if one of the hot dogs or all of the hot dogs, right?
yeah, because we reject the null if the p-value is like smaller than.
The overall or
Mhm.
alpha, whatever.
And then it's sufficient if it's lower, but it's higher.
So it's not sufficient, but we need to decide if we reject it because
Oh,
all
yeah.
of the hot dogs or it's
Mhm.
one of the hot dogs. Different. Another type. I would say.
Wait,
Go ahead.
well, I was just saying, I only have one question that says we do not have sufficient evidence.
Yeah, me too. So
Oh yeah, sorry. So we'll roll with that then.
Okay.
okay, guys,
Okay.
I'll turn it in.
I need to go to bed.
Okay.
They're all wrong. I'm gonna cry. We got an 80.
Which ones did we miss?
Okay. Number 3, 4, 5, 6, 7 is wrong. Does it give us the answer? Sorry, I have like blue writing in next to all my wrong answers, and it says 6. It's a miracle.
I wonder if we have 2 times for this test.
8 is correct. 9, 10, 11, 12, 13, 14 is wrong. It is the first one. Told me that. Oh, that's amazing.
Awesome. That would make sense.
15 is wrong, and it's the last one.
It's weird that it's like telling you.
Oh,
I
well, this
know.
one just gave me 2 answers. Maybe it accepts either or.
I'm gonna try
16,
that third.
it's good luck. It's either the top one or the third one. 17's right, and 18's right. Well, don't submit yet. You give me a second. You have to catch me up.
And then you said 17 or 18 was what?
Correct. They were both right.
Yeah, they were both right.
True.
Oh, 17, 18, right?
Yep. 3 true.
Okay, so I can submit it
Yeah, go ahead. 5.
and see, because that one that we put 8 was 6.
Mm-hmm.
6.
Okay. Let's see.
7, 6. 8, 24, or 27. 2, 0, 8. 53.158.
Okay.
True. 0.309. Right.
Okay,
so I got all of them right.
Yay.
Sweet. Which one did you put for, what's number 14, the top one? 15?
15's the last one.
The last
For 16, what did you decide, Jensen?
I put the top one.
Okay.
Top, okay.
17 is what number?
17.179.
Wow.
Even though it has like another arrow for the third one too, so I think either one would be okay.
That's
And
so
then-
weird.
Not
This is
sufficient.
why I don't.
Yeah.
Is this the second one, right?
Yeah. I feel like they
Sweet.
should do that to us on the exam where more than one right.
Me the 4.
Yeah.
Okay, well, then we're done.
Awesome.
We will meet Thursday for the test review.
Tomorrow, yeah.
Okay. Awesome.
Okay,
Whoa.
see ya.
See-
Yeah.